In this video, we are going to discuss about applications of multiplier ICs. So, the applications of multiplier ICs which are used for the following purpose. One is voltage squarer, frequency doubler, voltage divider, square rooter, phase angle reductors, and rectifiers. So, first let us discuss about the voltage squarer. So, we know this is a symbol of multiplier IC. So, if both the signal are same, so you will get V naught is equal to K into VI square. Previously, if you see the multiplier, if both the inputs are different, you will get V naught is equal to K into Vx and Vy. These two are my input, right? These two are my two inputs, and the K value is equal to 1 divided by 10, right? So, if the both the value of Vx and Vy is equal to Vi, I will get K into Vi square. So, this is nothing but a voltage square. Okay. So, here this diagram shows the multiplier IC which is connected as a squaring circuit. So, the input can be either positive or negative, and you will get the corresponding voltage which is between 0 to 10 volt. Okay. So, VA is my input voltage which is applied to the both the input terminal. You can see here. So, since Vx and Va is equal to Va, I will get V naught is equal to K into Va square. Okay. So, this circuit will perform the squaring operations, and this application can also be extended to the frequency doubling equations. So, let us discuss that one also. Okay. So, next is frequency doubler. So, you can see here I have given the input to the square wave circuit. One as phi sine 2 pi into 200 phi sine 2 pi into 200 10,000 T. Okay. So, if I give the input like this, what is the output I will get? Since V naught is my output, so I will get the output as, so you can see here I am getting the output as V naught is equal to K times VI square, right? VI square. So, what is VI? K is nothing but 1 by 10, and VA is here, they have given it as phi sine 2 pi into 10,000 T. Okay. So, phi sine 2 pi into 10,000 T, the whole square. So, this I can write it as, okay, 25 divided by 10 into sine 2 pi into 10,000 T, right? So, I can write like this. So, you know how to write sine square theta T, right? So, how to write sine square theta T as equal to 1 minus cos 2 theta, right? So, this is a formula. So, I can write this sine square 2 pi into 10,000 T is equal to 1 minus cos of 4 pi into 10,000 T. right? So, substitute in this formula. So, what is my V naught? V naught is equal to, here it is, sorry, if it is divide by 2. So, I will get 25 divided by 20, right? 1 minus cos of 4 pi into 10,000 t. Okay. So, we know this one, right? What is 25 divided by? This is nothing but 1.25. Okay. Minus 1.25 cos of 4 pi into 10,000 t. Okay. So, here you can see this is my DC term. Okay. This is my DC term. And here you can see this is 2 pi into this, this whole term I can write it as 1.25 cos of 2 into 2 pi of 10,000 t. That is, it is nothing but 1.25 of cos into 2 pi into 20,000 t. So, you can see the frequency get doubled. Okay. So, since the frequency get doubled, so if suppose my input is like this, okay, suppose if my, this is my, since it is a sine wave, okay, this is a sine wave, and they have given the input as 5 volt, right? This is my VA, right, with respect to time, okay, and so this is what they have given, right? It is VA is equal to 5 sine of 2 pi into 10,000, right? So this is my frequency, right? So T is equal to 1 divided by 10,000, right? So what will be my output? I am getting the output. So how the DC term will look like? So this is my DC term. So this is my DC term. Okay, and that value is nothing but 1.25. So upon this one, you will get a minus cos. Okay, minus cos term. So minus cos means it will start from here, right? So it will start from here and it will end here, right? So this is what the output you will get. Okay. So this is my output and this is my input. And this is nothing but my DC term. So next, let me go for another application, which is nothing but voltage divider. Okay. So the voltage divider circuit can be constructed using a multiplier and an op-amp circuit. Okay. So we will show that circuit. So this circuit will produce a ratio of 2 inputs here. So the division is achieved by connecting the multiplier and the feedback loop. So we see I have connected the multiplier term in the feedback loop. So this is my feedbacks because the output is connected to the input. So this is my feedback term. So here you can see I have used an op-amp and a multiplier. Okay. So at this point VA, the output is equal to 0 because of virtual ground, right? So I can write there is no current flowing through this terminal. So I can write I1 is equal to I2, right? Since the incoming current is nothing but I1 plus I2. So I can write I1 plus I2 is equal to 0. So what is I? I is nothing but current. So current can be written as V num minus 0 divided by R. Likewise, I can write VOM divide minus 0 divided by R, right? So I can write VNum divided by R plus VOM divided by R, that is equal to 0. So what is VOM? VOM is the output of the multiplier. So you know the output of the multiplier, that is K into the inputs what we are giving. So what are the inputs that I am giving? VDEN and VOA. So I can write VDEN minus into VOA, right? So from this equation I can write VNum plus VOM is equal to 0. So I can write VNum is equal to minus VOM, right? So from this I can write minus VNum is equal to K into VDN into VOA. Okay. So what is VOA? VOA is the output of this voltage divider unit. So that is nothing but minus VNum divided by K into VDN. Okay. Suppose VNum is nothing but let me take that is equal to VNum is equal to 20. Okay. So the what I am going to divide? So this is nothing but divided. The divided value I am going to give it in the VDN. Okay. So I will get the output as 20 divided by, this is nothing but 1 by 10. Okay, into 5. So you will get the output as and this is 1 by 2. So you will get the output as minus 40. Okay. So actually it is dividing this input by 20 by 5. Okay. So that is why it is called as a voltage divider. Okay. So here you can see the output. So with the help of this one, I can also with the help of this one, I can also construct a circuit called square rooter. So taken the divided voltage as DM, which can be used to find the square root of a signal by connecting both the input of the multiplier to the output of the op amp. Okay, so in this circuit, suppose this is also a VOA. Okay, so if this is also VOA, for square rooter, what will happen? So we know that VOM is equal to K into DN into VAA for voltage divider circuit. So in the square rooter, instead of VDN, I am going to connect it as VOA. Okay. So my VOM is equal to K into VOA square. Right. So and we know that minus VNum is equal to K into VOA square. Right. So what will happen? So you will get the output as minus VNum divided by K into root of this value. That is nothing but VOA. So VOA is my output of the square rooter, right? So VNum is nothing but the input. So I will get plus or minus VNum divided by K. So that is what the answer which we used to get, right? And we know the value of K is equal to 10, 1 by 10. So we will get root of 10 into VNum. Okay. So the V0 is equal to the square root of 10 times of the absolute magnitude uh, V num, that is my input voltage. So if input voltage is negative, or else the op-amp gets saturated. That is, if range of the V num is between -1 and -10, and the voltage less than -1 will cause the inaccuracy in the result. Okay. So the next one is phase drift. Okay, the next application is nothing but phase drift. So so here the phase this multiplier is configured for the phase angle detection measurement. Okay, whenever the two in sine wave of same frequency is applied to the input of the multiplier, so the V naught becomes V naught will have a DC component and an AC component. Okay, so for example, sine A and sine B is equal to 1 by 2 of cos A minus B minus cos A plus B. Since both the frequency are same, this one will get cancelled out. Right. So let us I will give you an example. Suppose if we see here, I am going to consider the two signal sine A and sine A and sine B, and A value is nothing but 2 pi f t. Okay, and B value is nothing but 2 pi f t plus theta. So here you can see the frequency is same, but there is a difference in the phase angle. So if that is the case, I will get sine A sine B formula is 1 by 2 of cos A minus B minus cos A plus B. So if I substitute in this formula, sine of 2 pi t, 2 pi f t, sine of 2 pi f t plus theta, I will get 1 by 2 of cos theta minus cos of 4 pi t plus theta. Okay, so this is nothing but 1 by 2 of cos theta minus 1 by 2 of cos 4 pi t plus theta. So here it is a DC term. This DC term will become 0 when theta is equal to 90 degree, right? So let me assume the two signal get applied to the multiplier. Okay, so this is my multiplier output. Okay, this is my V naught. So the one input is nothing but 4.47 of sine 2 pi into 10,000 t, and another input is 4.47 sine 2 pi 1000 t plus theta. 1000 t plus theta. Okay, so here you can see this is my 4 pi, this is my Vx. Okay, this is my Vx. So the signal is already there. Okay, since it is get phase shifted, so I'll get the output like this, right? So here it is, there is a 90-degree phase shift between these two. Okay. So whenever these two terms get cancelled out, I will get at theta equal to 90 degree. At theta equal to 90 degree, I get the output V naught is equal to minus 2 into minus 2 into 4.7 4.47 sorry 4.47 the whole square into cos of 4 pi into 1000 t plus 90 degree. Okay. So what is cos 90? Cos 90 is nothing but sin theta. So 1 by 2 4.47 the whole square sin 4 pi into 1000 t. So this is what the output I am going to get. So you will get and divide by k into k you will get since it is k times now, so you will get k and the k value is nothing but 1 by 10. So this is what the output you're supposed to get. So what is 4.47? So we'll get it is equal to minus 4.47 the whole square divided by 20 into sine 4 pi into 1000 t. Okay. Thank you.